work on this problem that gave us so much difficulty today. Owner of a gym reports that 96% of the time their gym has more than 500 clients, and 35% of the time the gym has more than 1,100 clients. So let's make ourselves a little beginning of a normal model here. Here's my 1, 1, 2, 3, 1 standard deviation, 2, 3. Well, 96% of the time the gym has more than 500 clients. And way down here is 0 clients, and way up here is infinity clients. So 96% of the time the gym has more than 500 clients. So that means I'm going to have some line about there, and up to this line covers 500 clients, and then above this line is more than 500 clients. So more than 500 clients, they told us, was 96%. So that means this line right here is at 4%. Well, now they've also told us that 35% of the time the gym has more than 1,100 clients. Well, now I know if they told me that 50% of the time the gym had more than 1,100 clients, it would be right there. We'd be right at the mean if it was 50%. But it's not 50% of the time. It's less than 50% of the time that the gym has more than 500 clients. It's 35% of the time. Well, one thing I do know, just so I can figure out where to place this 35% line, is that I do know that between here and here, I cover 68% of the data. So that means from 0 to 1 standard deviation negative is 34%, and from 0 to 1 standard deviation positive is 34%. Well, if I know that from here, the mean, all the way to the end is 50%, half the data, then I know that from the first standard deviation to the end is going to be 50 minus 34, which is going to be 16% of the data. Now they've told me that 35% of the time the gym has more than 1,100 clients. So that means that my line to determine where 35% is going to be somewhere in this first little section here. It doesn't have to be exact as to where it is, but it's going to be somewhere down here, because I know that from here to the end has to be 35%. 35% of the time, we're going to have more than 1,100 clients. Well, if 35% of the time we're going to have more than 1,100 clients, that means 65% of the time, so from here to here, we're going to have up to 1,100 clients. So 1,100 represents the 65th percentile. So now I have to figure out, I'm trying to figure out what are going to be the parameters of my normal model. I'm going to have an n something, comma, something. So I need to figure out the mean. I need to figure out the mean, and I need to figure out the standard deviation. Doing that is going to be a little bit tricky. So the first thing I'm going to do is I'm going to figure out, well, what kind of z-scores do I have here? Because remember, a z-score represents the number of standard deviations you are away from the mean. Again, if I'm at 0, let's find a different color here. If I'm at 0, then a z-score of 1 takes me 1 standard deviation to the right, and a z-score of -1 takes me 1 standard deviation to the left. A z-score of 2 takes me 1 standard deviation to the right. A z-score of -2 takes me 2 standard deviations to the left. A z-score of -1.5 takes me 1.5 standard deviations to the left. So all a z-score is telling you how many standard deviations you are from the middle to either side. Well, at 0.65, I did this one a second ago. At 0.65, I was just about the calculator. That is a standard deviation representing 0.385. So let's write that down there. That's 0.385. That is the z-score for 1100. So the z for 1100 is equal to 0.385. The z-score for 4%, a second, inverse norm, 0.04, negative 1.75. So I'm going to write that here. The z for this one is negative, z equals negative 1.75. Well, I'm starting to get kind of happy, but I still have a long ways to go. Because I know that if I want to calculate my normal model up here, my mean and my standard deviation, I'm going to need to figure out both of those things. And I have some of the data. So I know that y equals, I'm sorry, not y, z equals y minus y bar over s. So just looking at my 1100 number here, I know that 0.385 is equal to 1100, my y, minus y bar over s. I still need to do more to figure out my y bar and my s. So what I did was this. I said, okay, in terms of number of clients, here I have 1100. And over here, I have 500. So I have a difference here of 600 clients. And in order to travel 600 clients from 500 over to 1100, I had to walk, so to speak, a certain number of standard deviations. First I had to walk from the 500 to my mean right there, which was a distance of 1.75 standard deviations. And then I had to walk an additional 0.385 standard deviations. So the total number of standard deviations that I had to walk, oops, put them down before you push the button. The total number of standard deviations I had to walk was 1.75 plus 0.385. So I had to walk a total of 2.135 standard deviations to get from 500 to 1100 clients. So if I take 2.135, if I take 2.135 and I divide it into the 600 difference between the 500 and 1100, that's going to tell me how many clients make up one standard deviation. And when I do that, I get approximately 281. So 281 clients is my standard deviation. Maybe it'll look just a little bit better if I put the units on here. So I have 600 clients. It takes me 2.135 standard deviations. Let's just do it on the calculator. So I have 600 divided by 2.135. So 281 is approximately equal to 281 clients per 1 standard deviation. Well, that's part of the model that I'm trying to fill in. If my calculator will go away, there we go. So part of my n is 281. That's my standard deviation part. And once I found that, it should be pretty easy to find the mean. In fact, I can find it one of two ways. I'm going to use my formula z equals y minus y bar over s. So I had my z for the 500 was negative 1.75. Negative 1.75 is equal to 500 minus y bar divided by the standard deviation I just found of 281. Well, when I do that, I get my y bar is equal to 991.57. I can check it on my other side. Okay, I'll check it on my other side. I have a standard deviation for my 1100 of 0.385. That's my z for that. So 0.385 is equal to 1100 minus y bar over 281. Let's go over here and do it on the calculator. I'll get, let's go to that. I'll get 0.385 times 281 is equal to 108. I'm going to subtract 1100 from both sides, so let's write down our math here. I'm multiplying these two together, so that gave me 108.185 is equal to 1100 minus y bar. So what I'll do here is I will subtract 1100 from both sides. So 108 minus 1100, 991.815, negative 991.815 equals negative y bar, because it was a minus y bar, and when I make those both positive, I get y bar is equal to 991.815. Close enough to that. That's how I solve this. That's how I solve this problem.